All right, so we're learning about planes. Now we're very familiar with lines in three-dimensional space. Okay, so a line is going in both directions forever. It's a point plus a direction. All right, and so we're very familiar, like all the way up to year 11, we're doing lines on a two-dimensional plane, on the Cartesian plane. And now we're doing vectors, we're looking at lines in three-dimensional space, right? Well, another thing we can describe in three-dimensional space is not a line, but a plane. Okay, so it's not a line, it's a two-dimensional surface. And so think of a plane as like a sheet of paper, and it can have any orientation. And just like a line, it goes in every direction forever. Okay? So if we have a plane in space, this is the kind of problems we're going to start to deal with, is how does a plane interact with a line? Okay, we could have a line that is parallel to the plane, in which case they would never meet because they're both going in the same direction, never going to meet. We could have a line that's going to intersect the plane at one point and only one point. We could have it that the line lies on the plane. It's coincident with the plane. Okay, so we're going to learn about how lines interact with planes, but we're also going to learn about how do planes interact with planes. Okay, so the equation of a plane is very easy. What we need is we need the normal to the plane. So I'll just talk about that quickly. If this is the plane, the normal then is a line that is perpendicular to the plane at 90 degrees to every vector on the plane. Okay, so in order to find a plane, you need the normal. And the equation of a plane is this. This is its general form. AX plus BY plus CZ is equal to D. All right, where A, B, and C is the direction vector of the normal. Okay, so this is our first one. It has a normal 1, 3, 2. So that means my value of A is 1, my value of B is 3, and my value of C is 2. So to start our equation, we're going to have 1 lot of X plus 3 lots of Y plus 2 lots of Z is equal to D. We don't know this value of D yet. Now it passes through the point, X is 1, Y is 4, and Z is 0. So that means we're going to plug in those values into this equation in order to determine the value of D. Just like we would a line in y-intercept form. So I'm going to put 1 where the X is, I'll put 4 where the Y is, and 0 where the Z is. So this will evaluate to 1 plus 12, 13, which means the equation of this plane is X plus 3Y plus 2Z equals 13. Now just like we can sketch using GeoGebra and Desmos, we can sketch lines in 3 dimensions. We can also sketch planes in 3 dimensions, and that would be the equation that you can type in for it to generate the graph of the plane for you. Okay, now this plane, every coordinate that lies on this plane will satisfy this equation. If the coordinate does not satisfy this equation, then it doesn't lie on the line. Similarly, on the plane. Similarly, with a line, every coordinate that lies on the line satisfies the equation of a line. If it doesn't, then it won't satisfy the equation. It won't maintain the equation. Okay, question B, we have the x, y plane. So if we have x, y, and z are our axes, and we want to know what's the equation of this plane, this two-dimensional space, how can we describe it? So for a plane, we need a coordinate and we need a perpendicular vector. So what's the direction vector of a vector that's perpendicular to both of these axes? It's going to be the z-axis, right? If this is x and y, the z-axis is the one that's perpendicular, that's coming out the board, and that would have direction 0, 0, 1, 0, 0, 2, 0, 0, 3, doesn't matter, any scalar multiple of that would be correct. But this vector is perpendicular to both x and y. It's perpendicular to both of them. It's going to be perpendicular to the whiteboard, to this plane. And then we can pick any point that lies on the xy plane. Any point. All right. So we're familiar with lots of points that lie on the xy plane. Let's go. X is 2, y is 3, and z is 0. Okay. So if we're going to write out the equation of the plane, I'm going to do this in an elongated fashion again, just to familiarise you with the process, although this is rather a simple one to solve once you've got it. So we've got 0 lots of x plus 0 lots of y plus 1 lot of z is equal to d. Now you can go through like I'm doing here and just put the coordinates in like that, or like we've sometimes done in general form, you can solve for d straight away over here, which is, okay, I have 0 lots times the x coordinate plus 0 lots times the y coordinate plus 1 lot of the z coordinate. Okay, so 0x, 0y, that's just going to drop. We're just left with z. And then we have 0, 0, and 0. Z equals 0. Of course, that's the equation of the xy plane. Every coordinate on the xy plane has a z coordinate of 0. It's not placed off the whiteboard or behind the whiteboard. It's z, its distance off the z-axis is 0. So of course, that's the equation of the xy plane. Okay, so that's B. Let's clear some space and get into C and D. So here we have, find the plane containing the points A, which is 1, 3, 0, B, 2, minus 1, and 4, and C, 3, 0, 2. Okay, 3 points will compose a plane, right? If you have a point here and a point here, that's a line, okay? But if we have 3 points, that's going to make up a plane. Why? Well, because we have two vectors. Let's label them, and we can show it here accordingly. If we have AC and AB, okay, they are 2 vectors, and we want to know what is a perpendicular vector. We want to know what's a vector that's perpendicular to both of these. That's going to be the normal of our plane. How do we find that vector? AC cross AB, or AB cross AC. So let's find vector AB first, and vector AC. So vector AB will be 1, minus 4, 4. And vector AC will be 2, minus 3, and 2. Okay. Now, if we do that, then we'll do the cross product of them. And I've done this before, like my calculator, I've lost it, so I've just worked these out before. AB cross AC, I got 465. Okay, we can type that in our calculator. You can do it manually if you want. It's completely up to you. This vector, AB cross AC, is the one that's perpendicular to both of these. In fact, it's perpendicular to every point on this plane. All right, that's the direction of a perpendicular vector, which means the equation of our plane then is 4 lots of x plus 6 lots of y plus 5 lots of z is equal to d. And then we can sub in any coordinate that lies on the plane. That means all of these are going to generate for us that same value of d. So let's check. So let's put in A first. I have 4 lots of 1, plus 6 lots of 3, plus 5 lots of 0. Four and 18, 22. Now, if I put this coordinate B into here, we're going to see that it satisfies this equation, that the left-hand side equals the right-hand side, because B lies on this plane. We know it lies on the plane because we found the equation of the plane composed of the points A, B, and C. So it's a bit of a way to check that you're right, and I know some of the questions in the exercise will say, determine if this point lies on the line. So let's put the coordinates of B in. We would have 4 times 2 plus 6 times minus 1 plus 5 times 4. All right, so we've got 8 take 6 plus 20, we've got positive 2 plus 20, we've got 22. Okay, 22 equals 22, so it shows you that we've maintained equality, the point lies on the line. All right, we will go through D, and then we'll go through question 2 as well. All right, so thank you. So D is quite similar to this one, except we don't have 3 coordinates. We've got the equation of a line. So it starts at 2, 3, 1, and it has this direction. Its direction is 1 minus 2, 5. So we're not told another point, but we're told the vector that this point makes with another point. Okay, that's the direction in which it's traveling. And the other point that lies on this plane is 4, 3, 0. Okay, so you can think of it as like, this is vector AB, like we had before. This is vector A. I think we've defined the point as P, so we'll continue with that notation. This is AP. So we've already got vector AB. We want to know what is vector AP and then find the one that's perpendicular to both. So vector AP will be 2, 0, minus 1. And then we're going, all right, well, the normal to both of these lines is going to be AB cross AP. Okay. And I've got minus 2, 9, and 4. Okay, so that means the equation of our normal then is minus 2x plus 9y plus 4z is equal to D. And we can sub in any coordinate, it can be A or it can be P. Both of them are going to give us that same value of D. All right, so we'll have subbing in A. That's 4. Minus 4, 27, and 4 to 27. Okay, so that's our answer to D.
Where did you get AB from?
Very good. That's the direction of the line. So we're told contains the line from this point in this direction. Yep, so question D, containing the line 2, 3, 1 plus some parameter S multiplied by this direction.
So would you just, for point B, would you just make up any point on that line?
We don't know point B and we don't need to know it. In the previous question, we had point B and we used point B to find this direction vector because it's the direction vector that we want perpendicular. Here we don't have point B, but we already have the direction vector. That's all we need. Right. Yeah. We could go on and find point B by just subbing in parameter S being 1, being 2, being 3. We can find any point on that line. Good question. All right, question 2. Find the equation of a line that is normal to this plane, but passes through the point 1, 0, 2. Okay, so now we're reverse engineering it a bit. We have this plane here. This is the equation of some plane. Now, who can tell me, what is the direction vector of the normal to this plane?
2, 3, minus 1.
Excellent, okay. 2, 3, minus 1, that's going to be the normal. So now we have a line that has this direction, all right, but passes through the point 4, 3, 0. So you can think of it, right, like this is a plane, okay, and I want to know the normal, okay, this is the direction of the normal, it exists everywhere on this plane, but I want it to pass through a particular point, and the particular point is 1, 0, 2. 1, 0, 2 is here. Let's imagine it's right here. I'm pointing at it. You can see it. And so that means, well, it's not this normal. It's going to be here, such that that normal passes through that point. Okay? So all we have is 1, 0, 2 is the coordinate, plus some parameter multiplied by the direction, 2, 3, minus 1. That's going to be our answer for question 2. All right, we will finish with question 3 because 6H is a big exercise, so we'll stop with 3 and then we'll come back and do 4 and 5 a bit later together. Probably not this lesson, maybe Thursday. Okay, 3. We have determine where the line, I'll write it out, we've got x equals 3t, take away 4, y equals t plus 2, and z equals 2t take 1. Okay, this is a line, it's presented to us in parametric form. Find where this line meets the plane, determine where. Alright, so that means it wants a coordinate, it wants us to find a coordinate, and the plane is 2x plus y take z equals 2. So we want to know what's the coordinate when this line meets this plane. Okay, so think about it again. There's a couple of answers we could have. We could have that the line is parallel to the plane, in which case they meet for every value. We could have that the line is parallel, in which case they don't meet, or it's going to intersect once. Okay, so we're told find when they meet. When they intersect, we're looking for one coordinate. All we're going to do, this here describes every x value is 3t take 4. Every y value t plus 2, that describes anywhere on the line. So we're going to say, well, what value of t makes it satisfy this equation? All we're doing is subbing these into here. I have 2 times 3t take 4, okay, 2 times my x coordinate, plus my y coordinate, take away my z coordinate. Now be careful, the negative must distribute, so it's useful to use brackets. Alright, so remember how if a point lies on the plane, it's going to satisfy the equation. So we're saying what value of t satisfies this equation. Now all we're doing is going to expand that and solve through for t. We'll have 6t take away 8, and we'll have plus t plus 2 take away 2t take away 1. And we'll collect, we've got 6t, 7t, take away 2t. 7t take away 2t, that's 5 lots of t. We've got minus 8 plus 2, that's minus 6. Take 1, minus 7. And then we'll go 5t equals 2 plus 7, 5. 5t equals 9, t is 9 on 5. Okay, so that's the value of t that makes it true. So then we just go, all right, well, what are the coordinates when t is 9 on 5? When t is 9 on 5, we just put the t component in here to find x, y, and z. All right, so the x one's going to be 3 times 9 on 5, take away 4. So what's that? 27 on 5, take 20 on 5, 7 on 5. Let's use a calculator, I like this. So yeah, 7 on 5, we'll have 9 on 5, 19 on 5, and 18 on 5. All right. So that's question 1, 2, 3. That's enough to really get started with the exercise on planes. Yeah, any questions about what we've gone through there?
I didn't get a chance to do question 2.
Oh, question 2?
Yeah.
Yep. Yep, so you just want to have a quick chat about that again?
Yes.
Yep, sure. Yep, how about you guys? Same or yeah?
Yeah.
Good.